университета ИТМО. Вот мы поговорили про Бауманку.
That's ITMO booth. That's another university, ITMO. Everyone knows what ITMO is about. Everyone who wants to learn something about programming. ITMO trains the champions of the world. That's a kind of an incubator in terms of programming. Artificial intelligence zone. From ITMO University, we provide guidance for professional growth. Add more colors to St. Petersburg, and you will get the gifts. Cyber Summer in the city. And we now are going to announce a contest. You have to share your photos and pictures. Let us see them on the screen. That's our QR code. Please send your photos.
Вот по этому QR-коду переходите, проваливаетесь и присылаете ваши фотографии.
And send to us any your pictures. Let it be just any ladybug or a cup of coffee, whatever you want. And the best pictures would be selected by our colleagues. And you will be awarded a super merch.
Мы на сцену приглашаем.
And now we invite.
Фестиваль фотографий. Все.
This is called the Festival of Pictures. The chief director from Green Atom, Alexander Lubinsky, he will tell us about IT project on creating digital services for the Northern Sea route is arranged. So over to you. Please welcome Alexander Lubinsky. Hello. I hope that you can hear me well.
Здесь 10 минут назад было меньше народу. Это очень приятно.
10 minutes ago there were less people, and that's great that we have all gathered. And I will be happy to speak because it's quite warm there, but the place where what I'm going to tell you about is usually very cold.
Я буду рассказывать не о безопасности,
And I'm not going to tell you about the security,
безопасности с помощью цифровизации для людей,
but
которые работают в этом сложном регионе.
I will speak about the IT security in that region. It is quite hard for natural conditions because it is quite windy. It is not so sunny and quite frosty. And I tried to show that on some of my slides, and sadly. Still, it is beautiful. It is rich with natural resources.
Недр. Поэтому можно
It is full of
там очень богато.
subsoil minerals, so we can say that it is just very rich.
И, наверное,
But at the same time, it's quite quick and rapid, and you all probably know that the Northern Sea route, that's the fastest, the shortest way
морскому переходу
to
запада на восток.
go by sea from the east to the west and from the west to the east. So it saves about 30% time. This is a lot for the
Здесь такой
maritime navigation.
популярный сценный слайд. Я постараюсь сделать его.
That's a very busy slide, and we'll try to make it easier and simpler.
Что же там сложного-то вообще вот в
What is so difficult about that in that region?
сюда? Корабли.
To make sure that we have vehicles and we have vessels there. So
Корабли.
the sea is covered with ice. The
Ледокол.
ships cannot
Это, наверное,
go on ice. We need icebreakers. And an icebreaker, this is probably the most expensive vessel out of the civil ones.
необходимо придумать такую систему.
And since icebreakers are very expensive, especially for civil vessels, now we have to imagine a way for the civil fleet to work as efficiently as possible. And we had tens and thousands of vessels, but only tens of icebreakers. So there is a big difference in the order of the number of how many ships are available. So we will get back to this original slide again and again, because what can we talk about when we're talking about the Arctic region? Obviously, it's all about ice. We have to go through the harsh conditions, through the harsh environmental conditions, and even the most the best icebreakers cannot go through these areas. Even the best one, which will be built in 2030, cannot break all the ice, so you have to avoid it. Another point is that
Спутников там мало.
the communication is rather poor in the Arctic region because the cellular communication does not reach the high latitudes. And what can we do? Well, obviously, we have to go to the conference and speak at the conference, but we need to have systems which receive outside data. But since we work with big data, and I will talk about the data later, we need a very good communication channel. So, for this data to receive in time on the vessel, which takes the main decision on which route to take, it is important for the interface to be as simple as possible. Obviously, it will be complex, but you still need as simple as possible, because if there is a delay in receiving the images, obviously it will be too late to move left or right. Many countries which use the Northern Sea route have zero experience navigating through those areas, and you need helping them. You need to assist with the information. The captain has to be provided with information where to navigate, what are the checkpoints, and it's important to make so that there is no much responsibility on the captain, so that people who know how to navigate in these harsh conditions, you need to take this experience and then scale this experience to other vessels. But it's also very difficult to do. So the harder the problem, and the more difficult it is to scale up the work. We tried to do that, but we also want to alleviate their job as much as possible while streamlining business processes. Next point. When we're talking about digitalization of any business process, we have to have some foundations, data foundations, whatever we want to use to teach AI. If we're talking about accounting, we need a lot of accounting documents. When I talk about HR department, you need a lot of CVs, so different documents which are used in the HR departments. But there's just not enough data on the Arctic region, including the satellite images. So for you to have a little bit fun, I would like to say that we do not have too many satellites which would go around the Arctic region. So we do not know too much about that region. And obviously I'm talking about the civil part of those satellites, not the military one. What exactly do we militarize? What exactly do we digitalize, not militarize? What do we digitalize? We are working with the icebreakers so that they receive important satellite images, and the captain would see the ice conditions where they will be in 2 days. And obviously they use our system in order to receive those images. What else can we automate? Routing from point A to point B. That's basically a GPS navigator. You put the point and you get the route, considering all the potential problems and accidents that usually happens in the Arctic region, including the problematic ice, very harsh storms in the Arctic region. You might think it's very, very safe there, but it's actually very harsh. Maybe some military games, and all this are taken into account when routing from point A to point B. Next is the streamlining of business processes, because the government has to use the Northern Sea route, but also at the same time to navigate minerals. As I said, the Arctic region is rich with hydrocarbons, and that's the majority of the cargo transported there. That's LNG, oil, rare earth, mostly ore, and any ready-made products which are put into container. And as I said, it's 30% faster compared to other routes. And since it's faster, but it will be cheaper. Not exactly up to 30%, but it will be up to 30%. It doesn't have to be 30%, but if a navigation costs 50,000%, it will cost up to 30% less. And obviously there is less piracy in the Arctic region.
В этом арктическом регионе очень много. И это
There are many business processes in that region, and it's good.
рассказываю,
So when we're talking about the system,
реализовать и их тоже.
our system, it has to digitalize all those port services, logistics services, services to get the certification to be able to navigate in the Northern Sea route and many, many more.
Документооборот как следствие цифровизации бизнес-процесса.
So working with documents,
Безопасность. Вообще,
security and safety, I would say.
вот здесь есть лазерная указка. Смотрите, я показываю. Вот там логотип Росатом. Почему?
Take a look at this. This has the Rosatom logo. So why Rosatom? Rosatom is responsible for the Northern Sea route,
Институциональным оператором этого
and it is an integrating
всех процессов.
governmental operator for all the processes that happen up there in the north.
Мы разрабатываем.
And exactly in Rosatom, where we develop this digital platform. And the main task
Росатом это обеспечение
set by the government for Rosatom is to provide safe and secure
на Северном морском пути.
annual navigation in the Northern Sea route. So this is the main task what we do.
Чтобы вы услышали, что все, что мы делаем, это мы
I want you to hear that what we do so that it would be safe and secure to navigate using vessels
дальше.
in that area.
Мы сделаем это безопаснее. Я чуть позже расскажу.
So how do we do this? I will tell about it later.
Эксплуатируется в Арктике. Моментально выходит из строя.
Whatever we use
Не потому, что
in the Arctic region
условия эксплуатации, в том числе и все корабли, все телефоны.
has to be
я не знаю,
repaired, has to be maintained
все это
because of the harsh conditions. You spend more resources, you spend more time, not because it is bad hardware, but because, as I said, because of the harsh conditions. And all of that is the responsibility of Rosatom.
мы такие, и что мы делаем?
So a few words about ourselves and what do we do.
Так называемые
We have
пользователи, любые организации, которые
internal
участвуют в Росатоме, и внешние пользователи. Вот
customers and we have external customers. So internal customer is the state corporation Rosatom,
который владеет, ремонтирует,
Open Fleet, which
очень организация. И гидрографическая
builds
организация,
and owns icebreakers, and a hydrographic organization that provides maps and navigation charts,
важна с точки зрения картографии.
which we obviously need to use. And charts are very important for us. And obviously, there are external customers. Those are mostly resource companies of Russia and other countries too. Those are companies that work in different ports. Not too many, unfortunately. Hopefully, will be more,
регионах.
especially when we're talking about the Arctic region. And ecological companies,
Значит, махиной
educational organizations,
мы с-
penitentiary system.
значит, со всеми,
Penitentiary systems are also included there,
собственно говоря,
with whatever they have to do there.
это те
And mass media.
мы делаем эту
Those are the customers we create our system for.
единая платформа цифровых сервисов Северного морского пути.
This is our website, arctica.rosatom.ru, which is designed to provide security,
на Северном морском пути.
safety and security for the navigation in the Northern Sea route.
Возить по этому
We
маршруту.
have to
Это очень много.
increase
Когда-то было всего 10.
the capacity from
Загрузы
30 million tons to 100 million tons, and this is a lot. Mainly it's hydrocarbons and different containers, because the navigation in that area from the west,
очень большой.
rather from the east to the west, is rather large. And even though there are many polar bears and icebergs and many other
Гораздо безопаснее.
potential problems, still it is so much safer than to go through the Somali pirates.
Развивается конфликт.
And this is another problem. This is exacerbated by another problem which are now growing in the Middle East, especially Yemen and other countries.
Но это ничего. Мы создаем информацию для судоводителей, предоставляем
Next, we provide information for navigators. We provide information, weather charts,
а также услуги ледовой
and port services,
Можно заказать ледокол,
and
он тебе обеспечит
iceberg services. So you can you can
Мы цифровизовали процессы для перевозки.
request
Это
the
отдельный
assistance of
услуг,
an
логистический.
icebreaker, and it will
Сложность в том, что
accompany you along the way.
нужно учитывать грузы,
We are working with the transportation systems. We have to take into account the cargo which are being transported. So we had to reinvent logistics specifically for the Arctic region. And we had to reinvent it because all the processes are accompanied by extra but critical components and critical circumstances. So, for example,
топливом,
fueling of a tanker
превращается в целое там приключение. Например,
will become basically an adventure, heroic feat in the north, because you cannot reach the port. So first you have to request the assistance of an iceberg, then you will.
заплатить за это, за портовый сбор.
Basically, it's a very complex situation. You cannot just reach the port. You have to use the assistance of the icebreaker, and obviously pay for the work done by the icebreaker. And we need to automate all those business processes.
Назвали базовую функцию.
Ice Navigator is the basic function of our digital platform.
Я уже сказал, позволяет сделать много вещей. но
This makes it possible to have
всех неприятных
different functions, but the main one is to avoid all the problems when you go through the sea route. You put point A and point B,
с его
and the system always knows
ходовыми качествами,
your vessel,
характеристиками и другими.
your capabilities and technical capacities, how fast can it go, how sturdy is this vessel, and you will have the route for your specific vessel, just like
Можем это делать.
Yandex Maps. So how can we do this?
Самое главное,
That's the main point. That's the main problem,
проблема, да,
which I will cover later.
которую мы решаем.
I would even not say it's not exactly a problem, it's scope of our work. So this is what we need to do. We have to
Обстоятельства гораздо сложнее, чем
navigate the route without knowing everything in details. And obviously it is much more
чем на
harder,
Москве или
much harder to get precise information on what happens in the Arctic compared to what happens on the streets of Moscow.
миллион раз.
And we also do not have as much information as we have here in Moscow.
Там станции наблюдения.
We have no data sources. We cannot have
Над Арктикой спутники есть такие программы.
research stations or observation stations. Maybe we'll be able to have satellites which will go around and above Arctic region.
Глобально, конечно, это
Currently, we do not have this. Maybe it will happen in the future, but we have to deal with what we have right now. We were able to locate about 70 sources, and currently we have more than 100 sources for data.
вот эти источники, это сама
And those sources
4 года назад,
are the biggest problem. 4 years ago, when we started the process, we had connections with the European Space Agency,
22 года.
and after 2022, we've lost those ties. We had
Пока. И что же
communication with NASA, with lots of space satellites, and we also had to say goodbye to them. So we had to work with what we have in our access. So what does it mean? It means that we had to rework all the mechanisms, all the systems during the last few years,
Значит,
and we create those unique forecasts.
все пользуются
Probably everybody uses
погодой. Да, я уверен, что все смотрят
weather forecasts. I'm sure you even watch it on TV, or at least you check it for today, for tomorrow, using your iOS devices or Android devices. Companies which calculate
И вот,
and those forecasts are just two companies in the world, and both of them are not available for us. There is a Russian company,
погоду.
Russian
Потому что для того, чтобы
Hydro Center,
допустим,
and it also tries to calculate, but it's not as good as those two. The reason is that you want to calculate the speed of wind,
поэтому
humidity.
считать где-то рядышком погоду, ну,
You need a lot of data.
погодушку, извините,
And if you want to calculate the data in a certain region,
и погодушку
you need data from the weather in the next region. And if we go cluster by cluster, We have to know weather across the globe in order to know the weather on the Northern Sea route.
По-хорошему. И это
That's the best case scenario, and this is what's done.
погода.
That's the
Погода.
model of global weather forecast. And there are places on our planet.
Нет? Ладно. О, спасибо. Тут картинка красивая просто. Я без нее не...
That's a beautiful picture. That's a really beautiful picture.
Есть места на планете, которые являются
There are places on our planet that are sources
метеорологического явления, драйверы.
for
Драйверы погоды.
different meteorological events. They are weather events.
Где-то холод.
There are places where
Там, где много льда,
the frost is born, where wind is born, where tornadoes are born, and so on. So, and obviously, many of them are born, so to say, are born in the Arctic region. There is a lot of cold which is generated, for example, above Greenland.
можем использовать вот эти вот открытые данные по...
But at the same time, we can use open source data on temperature and wind.
Потому что по
We also need to have forecasts on the water because
можно
that's the media
и температура.
which we use for our vessels.
Сложные вещи, они у нас есть. Это
I will not go into details, and obviously we have this. We use AI. We have a lot of calculation capabilities.
стоимостей.
Absolutely enormously expensive. So if you learn how much it costs, please do not be surprised.
Порядка, ну, да.
I think it's about
Посмотрите, сколько это стоит. Это
if you just learn about how expensive it is, there is a reason. There is a good reason. We need to forecast additional levels, especially the sea level. We need to know the sea level, and we need to know the changes at the sea level, how it changes and how fast it changes. Then we create our own unique forecasts. It's not from Russian Hydro Meteor Center. It's not from NASA. We create our own, and we analyze ice. We see where it moves and how fast it moves.
именно такое. Значит,
And
сжать
here's the point.
и
Compression of ice and its
нам нужно обязательно
type.
предсказать,
We have to forecast at what place and the
движение всего лишь
strength of compression
сеткой
for ice, and do this for 7,000 kilometers. And the resolution will be only 3 kilometers.
Давайте
We have to forecast the level of ice compression.
посчитаем.
So maybe this is the exercise for us to do. Obviously, this is a very, very difficult thing to do.
Отдельным видом интересных IT-событий в нашей системе стали уникальные продукты.
Another point for unique IT
Как оказалось,
events is the distance,
но в
is
первый
the remote
в мире делается в первый раз. И делается вот
Earth
внутри Росатома.
imaging.
А как оказалось, просто
And it turns out that just to it's not enough to show what happens around the globe right now. Even though we do not have enough satellites, still we can have
научились предсказывать.
a rough picture. We've learned how to forecast
С высокой
with high precision,
я надеюсь, аудитория здесь
with
подготовлена, понимает разницу
high accuracy,
необходимостью.
and I believe you understand the difference between accuracy
7 минут осталось.
and precision.
Спутник радиолокационной съемки. Сейчас тоже
So
будет.
we have
Это такая микроволновка, которая летает на орбите,
we
светит
have a certain satellite which
углом.
goes around the globe and shoots a beam
Вертикально, другая
at
горизонтально.
a certain angle.
Она зачем это?
We have multiple beams. One of them are vertical, one of them are skewed a little bit.
Попала
And
обратно.
it does it for a reason, so that this way would be reflected and goes back to the satellite. And then these data are taken and sent to the base station. This microwave, which sends the beam vertically, is vertical polarization, and the one which sends it horizontal is horizontal polarization.
Каждый пиксель
And
содержит,
that's just a set of data. Each pixel
я не буду
contains
бита, ну, наверное,
64-bit,
короче, 60 тысяч значений,
60,000,
60
about 60,000 pieces of value from a single point.
на Земле.
The problem is that those objects look exactly the same from the point of view of the satellite. Be it a hair, be it a Luzhniki Stadium, it looks exactly the same for the satellite. So what do? We've taken the AI and we taught it how to use those images. So those microwaves going around our globe, they do not shoot their beams exactly at the right angle. There is a certain skewed angle. So we taught them how to reduce the noise from those images. You can see the difference between those images, one with the noise and the other without the noise. Those were the pieces of those images. Then we separate them into different components. Each pixel contains about 60,000 pieces of value which we can use, but not all of them are valuable. So a few thousands of them, even 300 to 400 of those pieces of information are useful. But to calculate them, we had to work with a number of different AI systems. Then we apply textures so that we can make a difference between rubber surface and asphalt, for example. Then we present it to our ice experts. And how many ice experts do you think we have here on the planet? Well, obviously, just a few, I would say. Not so many, not enough, obviously. Probably we had more ice experts before, but they did not have access to modern technology. So those experts use these images and then they separate water from ice, and they do this manually. So first you have to find the experts, you have to provide them with the images, then they have to separate water from ice manually, and obviously they have to receive the money for the work they do. Next, we compare the results of their work, and we say, so this is what ice looks like, and this is what water looks like. Based on their reports, these are the diagrams we have. Next, we use three main techniques. One of them is gradient boosting, vector mapping, and we use different ways to teach AI, and we provide this data for convolutional neural network. And if you care, I can talk about deep learning a little bit. Yeah, it was just like the Canadian Prime Minister was asked what the quantum computer was, and they started to laugh at his response. So my point is that the first technique is that uses different vectors. There are many multiple points, and you have to write a single line that will be as close as possible to all the points. So this is the technique of quadratic deviations. And just imagine you have different points in 3D environment, and you have to draw a line which will be as close as possible to all the points. And the next is the gradient boosting. This is a technique. Everybody knows about the decision trees, where you have a single branch and it goes left and right, and this is the kind of trees we have. So gradient boosting is a simple sequence of those trees where the next tree corrects the results of the previous tree. And it happens for millions and millions of times. So this is the gradient boosting. Between those two techniques, between those two incidents, there is a gradient. And gradient is the knowledge of how previous, how much of an error was
Таким образом, сильно улучшает
allowed during the work of the previous tree compared to the next tree. And because of this knowledge, it is possible to significantly improve the forecast capabilities. And finally, neural network, convolutional neural network, and they're different from AI, is that they look at the cat not as a cat, but they look at an eye, they look at the paw, and then they understand that as a whole, that's a cat. Usually AI does it in a different way. Well, neural networks doing it in a different way. Here we understand where we have water and where we have ice. We've got the image, and based on this trained model, we've got the automatic result. And that's actually the most important part of the project. Next. We calculate ice forecast. As I said, we don't have enough data from the satellites. And here's the problem. It's oftentimes very, very... So we cannot use optical images because of the weather. It's overcast, and half of the year it's dark there. For an icebreaker to reach any type of ice, an icebreaker is a great vessel, but ice doesn't like water. And the reason is that it does not have any ways to stabilize itself. What they can do is go a little bit deeper. And icebreakers really, really do not like water. They can go through ice, no problems, but really hate water. Icebreaker cannot go from the north to the south because the temperature beyond the board cannot exceed 15 degrees Celsius. I'm talking about atomic icebreakers. So the ice is very different, and we can diagnose it in different ways. We can discern different types of ice, because thick ice is very, very dangerous, and thin ice is not dangerous. So we have heat maps, we have different color gradients, and you've seen them before in the presentation. Meso-scale polar cyclones. Obviously, there's a very high wind and storms and hurricanes, but they appear very, very fast and they pass very fast. But the temperature, the speed, is considered dangerous from 30 kilometers per hour, and the waves from 6 meters. If it's not 30 kilometers per hour, if it's not a 6-meter wave, then it's not dangerous, at least in the Arctic region. Here's the animation and the result of our work. This is what we spent hundreds of millions of rubles to forecast the speed and to forecast the height of waves. And you can see the speed of wind and the height of wave. That is why we have the unified digital platform for the services, and we have more than 70 cross-integrations which we use for different information sources. And just a little, the last thing. 1 minute, just 1 minute. The Arctic region is a very, 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 very fragile region. Any changes in the ecosystem of that region will significantly affect all the other systems and subsystems in that region. You don't have to believe this, just trust me, or you can check it for yourself if you want. If in our system we automated the processes of ecological monitoring, you cannot go there, you cannot litter there, and without any fines, without any punishment, we will be able to find you. We will find you, and we will punish you, so to say. And we're collecting the database knowledge because we are working at the research institute, and we were able to do and provide all the necessary information. That's an absolutely honest screenshot of our system for the ecology department. We are following the plankton, we're following the panthers, different mammals, different birds. We do not use any devices, but we know them from other sources. We are looking through hydrology, and I mean 300 parameters for acidity, for the content of salt, and so on. We are talking about the waste management. Obviously, this is something we have to manage. When there is a vessel going on, there are exhausts, and we calculate how much it exhausts, and we see how well it does. Then we calculate all the potential problems with CO2.
Also, we have split our system into subsystems, and we show special environmental zones where the vessels are prohibited to enter. And we render that data so that that information is conveyed to the pilot of the ship, and it is penalized if it does so. So we made that for Rosatom, and that's about the security and predictability of navigation. One-stop shop access to the data that you will need for navigation in the Arctic region, and one-stop shop approach to rendering information and data within the Northern Sea route. Whatever you need from the Northern Sea route, please approach us, and thank you so much for your attention. So if you wanted to somehow pilot a caravan along the Northern Sea route, so come to Alexander. And thank you so much to our next speaker, because he's several minutes late, and let's stand in the middle of the stage. So first of all, people wonder for hot potato and lust for hot potato, so that competition is never over. And speaking about sovereignty, this is our sovereignty, right? China is also nearby, the main manufacturer of everything. And if we really can carry up to 100 million tons, we will be secured against anything, because we'll not be led either to the Black Sea, to the Bosphorus, or to the Baltic Sea. So what we do, we can use the Northern Sea route. And we have the longest shore, about 18 million kilometers, 11,000 kilometers, and I will not grudge money for that. Okay, and those microwaves that are flying on top, are they made in Samara? Yes, we have some of them, yes. Or probably they're made in South Korea now. We checked with China, sadly. Sadly, we rendered so many information, so, and Indians also flying, so we also granted them with some technologies, and now they are paying back. So it's kind of an exchange. So we launched them, and they did some extra development, and probably they will catch up with Roscosmos. Okay, and gradient boosting system. That was just great. Well, this is very, very interesting. And what about the weather link, actually? This is just a short version of weather. Okay. And thanks to those four letters, ECPC. So remember those four letters. This is synonym of our sovereignty. If necessary, I will be staying there next to that flag. They will torture you to death. Okay. Minatom and Rosatom have a booth, and there's a game you can play, being a master of the icebreaker, how you pilot different ships along the Northern Sea route. And if you want to work with us, you may get an internship. Our Western partners also are very much afraid of our ice-breaking fleet, because it is very cool. And this is 100% made in Russia. Icebreaker simple substitution is very high, almost 99%. And in 2030, actually, the most powerful icebreaker would be called Leader, not Lenin, but Leader. I didn't know that